Alright, so for this video, I'm going to be solving the equation x to the power of 4 is equal to negative 9. So what I'm first going to do is add 9 on both sides. So then these two cancel out, and I get x to the power of 4 plus 9 is equal to 0. Now from here, I can rewrite x to the power of 4 as x squared to the power of 2, and I can rewrite 9 as 3 squared. And if I have something in the form a plus b squared, this is equal to a squared plus b squared plus 2ab. And if I have something in the form a squared plus b squared, then this must mean that this is going to equal a plus b squared minus 2ab, because this is the same thing as this without the 2ab. So this means that a is equal to x squared and b is 3. Going back over here, so I get x squared to the power of 2 plus 3 squared is equal to x squared plus 3 squared. And this turns into x squared to the power of 2 plus 3 squared is equal to x squared plus 3 squared minus 2 times x squared times 3 is equal to 0. So now from here, I get x squared plus 3 squared minus 6x squared is equal to 0. And remember how the square root of 6 squared is equal to 6. So what I'm going to do is I'm going to rewrite this as x squared plus 3 squared minus the square root of 6x squared is equal to 0. And the reason I did that is because now I can use the property a squared minus b squared is equal to a plus b times a minus b. So in this case, this turns into x squared plus 3 plus the square root of 6x times x squared plus 3 minus the square root of 6x is equal to 0. So this gives me two equations. I have x squared plus 3 plus the square root of 6x is equal to 0, and x squared plus 3 minus the square root of 6x equals 0. So for both of these, because both of these are quadratic equations, you can use the quadratic formula to solve them. So by using the quadratic formula, I'm actually not going to do that in the video, but you can try that yourself. You should get that x is equal to the square root of 6 times negative 1 plus I over 2, and x is also equal to the square root of 6 times negative 1 minus I over 2. And also, along with this, you should get x is equal to the square root of 6 times I plus 1 over 2, and x is equal to the square root of 6 times times 1 minus I over 2. So these are your four solutions. Alright, so in this video, I'm going to be solving the problem 100 to the power of x is equal to 10 to the power of x plus 1 to the power of x. So, to solve this, what I'm first going to do is rewrite 100 to the power of x as 10 squared to the power of x. So now this is equal to 10 to the power of x plus 1 to the power of x. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of n to the power of m. So 10 to the power of 2 to the power of x is equal to 10 to the power of x to the power of 2. So now I have 10 to the power of x to the power of 2 is equal to 10 to the power of x plus 1 to the power of x. Now, if I have something in the form, 1 to the power of any number is just going to be 1. So we can just get rid of this x as an exponent because it won't really change anything. So now I have 10 to the power of x squared is equal to 10 to the power of x plus 1. And now from here, I'm going to let 10 to the power of x equal to the variable m. So now I have m squared is equal to m plus 1. And this turns into m squared minus m minus 1 is equal to 0. Now I'm going to use the quadratic formula to solve this. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is negative 1, and c is negative 1. So I get m is equal to negative of negative 1 plus or minus the square root of negative 1 squared minus 4a is which is 1 times c, which is negative 1, all over 2a, so 2 times 1. And this turns into positive 1 plus or minus the square root of plus 4 over 2, which is equal to 1 plus or minus the square root of 5 over 2. So this is the value of m. And to be precise, the two values of m are 1 plus the square root of 5 over 2 and 1 minus the square root of 5 over 2. Now, remember how we let m equal 10 to the power of x. So 10 to the power of x is equal to 1 plus the square root of 5 over 2, and 10 to the power of x is also equal to 1 minus the square root of 5 over 2. So for my second equation over here, 10 to the power of x is equal to 1 minus the square root of 5 over 2. Well, 1 minus the square root of 5 over 2 is a negative number. And you can't take the power of a positive number and make it equal negative, meaning there's no solution to this equation. So we are only left with 10 to the power of x is equal to 1 plus the square root of 5 over 2. And to solve this, I'm going to take the log on both sides. So I get log 10 to the power of x is equal to log 1 plus the square root of 5 over 2. And if I have something in the form log a to the power of b, I can move the exponent b to the front, so this turns into b times log a. So now I have log 10 to the power of x, which I can move x to the front, so I get x times log 10 is equal to log of 1 plus the square root of 5 over 2. And now I'm going to divide both sides by log 10. So then these two cancel out, and I get x is equal to log of 1 plus the square root of 5 over 2 over log 10. And log 10, if you guys already know, is equal to 1. So this turns into log of 1 plus the square root of 5 over 2 over 1, which is the same thing as log of 1 plus the square root of 5 over 2. There's no need to include the over 1 because anything over 1 is itself. So this is my solution to this equation.